So we've talked about how we can find the derivative at a point. And now we actually want to talk about finding the whole derivative function. So that if we want to find the derivative at multiple points, we can find one function and then just plug in those x values and get the derivative at those points. And we're actually going to use the difference quotient, but instead of putting in x0, we're just going to put in x. So we say the derivative as a function, f prime of x, is equal to the limit as h goes to 0 of f of x plus h minus f of x all over h. So we're just going to use an x instead of where we had an x0. And in the end, instead of getting a number, we'll get an expression, a function. So we're going to use this to find the derivative of f of x equals 1 minus x over 2x. So we're going to take the limit as h goes to 0. First, everywhere where there's an x, we're going to plug in x plus h. So we're going to have 1 minus x plus h over 2 times x plus h minus f of x, so minus our function, all over h. So two things that it's important to know is, one, you always need to write this limit as h goes to 0, and always write this over h until the end. Otherwise, you'll forget you're taking a limit, or you'll forget you need to cancel out that h. So to simplify this, the first thing I'm going to do is distribute the minus. So 1 minus x minus h. And I'll go ahead and distribute that too. So 2x plus 2h. Now, to combine these for these rational functions, we need to do a common denominator. So we're going to have to multiply this first one by 2x over 2x. We're going to have to multiply this one by 2x plus 2h. Okay, so remember, always write that limit. So for this first one, we have 2x times 1 minus x minus h. So if I distribute that 2x, we're going to have 2x minus 2x squared minus 2xh. And this is all going to be over 2x plus 2h times 2x. That's all over h. Okay, now I need to FOIL the second one, and it's going to be subtracted. So when we FOIL, we're going to get 2x plus 2h minus 2x squared minus 2xh. Okay, so you can see, if you're really careful here, these do get pretty complicated. So we're going to have the limit as h goes to 0. I have 2x minus 2x squared minus 2xh. Distribute the minus, so minus 2x minus 2h plus 2x squared plus 2xh. Now, one thing that will make it a little simpler, this h, remember when you divide by a fraction, you multiply by the reciprocal. So the h, if we multiply here, would be by 1 over h. Right, so these cancel out, and we just get an h in this denominator. So we can write this as one fraction and do 2x plus 2h times 2x times h. Okay, so we're still taking the limit as h goes to 0, and now we're going to simplify as much as we can. The 2x's cancel out. Minus 2x squared and plus 2x squared. Here we've got minus 2xh and a plus 2xh. So the only thing we're actually left with in the numerator is a minus 2h. And in the denominator we have 2x plus 2h times 2x times h. And now we can see that we can cancel our h's. And now we can take the limit as h goes to 0, so we can plug in 0 for h. And when we do that, we get negative 2 over 2x times 2x. And so our final answer, our derivative here, is negative 2 over 4x squared. And if we want to simplify it as much as we can cancel out a factor of 2, and we have negative 1 over 2x squared. So that's actually our derivative. F prime of x is equal to negative 1 over 2x squared. And that means if you wanted to find f prime of 1, you would just plug 1 into that function. If you wanted to find f prime of 7, you would just plug in 7. So it gives you one function so you don't have to do it for each individual number.